Hey, how's it going? We're going to be doing some Pytorch today. We're doing some Pytorch. We're going to see if we can track the user's clicks and then predict where their next click is going to happen. We're going to see if that's possible. I think we're going to get pretty close. I think we can train it to at least, if we have a common pattern, like we click once and we click back and forth, we can get the AI to sort of predict that click pattern. So I think we should be able to get the AI to do some sort of nice little predictions like that. Now, of course, obviously, if you click randomly and you never click in the same place twice, then it's going to be a little more challenging. It'll be a little bit more challenging, although I think it's possible. I think we'll get pretty decent. I think we'll be pretty decent here. All right, let's see. I'm going to click and I'm going to get some things set up here. Getting a little bit of things set up. One moment. Okay, so not that one. Maybe it's this one. All right. Just clicking a few buttons here really quick. Click this. Is that the one? We're going to find. Yes. All right, cool. Excellent. Okay. Copy. Looks good there. All right. Let's do a pin on that. Rocket symbol. 1 second. There we go. Post. Okay. All right. Let's see here. How's it going? All right. So let's get this. Oh, wait. No, wait. There's one other thing I forgot to do. One moment. I almost forgot. Let's see here. One moment. Button. Okay. That one. Let's see. Do pre. All right. It's getting set up here. It's getting set up. All right. I think this is the one right here. Okay. And then we go over here and then we click. There we go. Done. Okay. Save. Perfect. All right. That was a lot of clicking in the internet. That's a little more clicking than usual. All right. So we've got our code here. I'm really excited about this. We've got our encoder, and we did it wrong. So I did look up a little bit over the weekend. Whenever you're dealing with a B2 compose with any of the basically encoding, so you're taking in raw data. You're consuming the raw data as input into the model, and we need to normalize it, and we need to convert it to a tensor. When you're running it with a lambda or any other method, you need to be able to capture just the first element. I would be so nice if I could say X, a whole bunch of extra, like get it to use exactly the way I want. However, it's not going to be that way. Also, I need to create a tensor normalizer. I was looking this up. We need to normalize the tensor, create a normal buffer. So it's essentially a normalization buffer. And that's what we need to do as well. So we will be heading on that. We will make that. We will make it here in a moment. All right, let me click on this over here. Clicking. 1 moment, reload that. Okay. Just making sure everything's set up here. And then we're going to dive into it. And then we're going to start. By the end of today, we will have our click predictions up and running in a pretty decent model. Pretty okay model. I'm pretty sure about that. Okay. So here is our code. We're all set up here. I'm double checking that everything looks good on my side. I've got all the pieces that are set up. I do believe that is correct. Let me double check. All right, so let's reload that. Just checking on a few things. All right, I think we are looking good. Okay, excellent. All right, so first thing is first. We have some of our docs are up here. We do need to be able to be running on the desired device by default. So let's get this set up here. So I need to be able to capture the device. Let's get this. All right, where do we want to do that? Where maybe on a init. Why don't we do that here? Let's do that here. I think that'd be great. Maybe. All right. Self.device. Okay. This should be fine. I think we'll be fine with this. Okay. So this is the modern approach when you're using Pytorch. This is the modern approach to capturing the current accelerator. So you have a default device. You can update the default device. It is set to CPU by default. We should probably keep it to CPU. When you want to set the parameters, transition those from CPU system memory over to your GPU memory. You need to run set device on it. So that's what we're doing right now. Hey, Karma, what's going on, bro? We're gonna finish off from last Friday. We had our clicking, right? The users can click on the screen, and we'll have the AI predict it. By the end of today's stream, we will be done with. We should have it running. It should be running perfectly fine. So we need to do a few things before that can happen. We need to do encoding. We need to do decoding. We need to make sure that we're running on our accelerator. Although we really don't have to, because this is just one input every time the user clicks. So there's absolutely no need for GPU acceleration here. In fact, we'll probably be slowing things down. We're making things slow down probably by doing it. Awesome, let's go. All right, let's go. I'm really excited about it. I think it'll be pretty neat. So we're just getting a few things set up here. So we've got this. Let's add a to-do here. To-do use GPU, question mark. We probably don't need to use the GPU. Ava Griffin, how's it going? Hi, yo, hi. Good to have you here. We've got our GPU, we've got our AI set up here. We're gonna make things happen. And so this is a to-do item. There's no need to use GPU for our current use case. It's going to be CPU. The batch size is going to be 1 every single time. Although I suppose what we could do if we wanted to make it more efficient and we had a lot more clicks, we could batch them together and then train them in batches. That's where you get the acceleration. That's why you have the acceleration on that. Okay. So we've got our model. Let's see here. Where does a model at? Model. Okay, model. So I would rather put this in the right stack order based on definition. You encode the data, you run it through your model, and then you run it through your decoder. So we should have a decoder here as well. So let's do self.decoder equals none. We need to do something here. We basically have to do the opposite. We have to do the opposite of this encoder. So do the decoder. All right, excellent. Decoder's there. Okay, looking good. Excellent. All right, so we've got a normal model. Model looks fine. Might want to make the model a little bit bigger. I think we should be fine with that. This is, instead of saying using the accelerator device is, I think that's a little bit better, saying accelerator. Ecouter? You've been hacking? Yeah, we be hacking. That's what's happening right now. We're hacking some AI. We have an application that Quantified Quantum wrote that allows you to visualize clicks. Then we're going to capture those clicks and we're going to predict the future. Where is the user going to click next? That's what we're going to do. Neva, how's it going, Neva? Good to see you. Happy Monday. We're continuing from last Friday. We're continuing our stream from last Friday. We have needing to get our encoder up and running. And I did look through this. So the X, the problem was I was trying to do this. I was trying to say XY. Whenever you do a lambda in your compose, I looked this up. Doing okay, nice. Trying to learn Haskell. Ooh, we got some functional programming happening here. Is that what we're gonna have? We're gonna Haskell some functional programming. Haskell's great. I think Haskell's great. It's very often, I've always referred to it as a research language, because we don't really see a lot of Haskell in production, right? We don't see a lot of Haskell in production. It just doesn't happen. Don't see a lot of Haskell in production. All right, let's see over here. What do you talk? Why do you talk some Red Dragon Reborn? I don't know. Because otherwise, I guess what the opposite would be, it would be not talking at all. And so if you were to have one or the other, which one would you prefer? I'm telling you what's happening here. So we need to fix this here. Facebook apparently uses it sometimes, but yeah, do they? That's awesome. I had no idea. Facebook is very bad metric for what programming languages are good. They created hip hop. Do you remember hip hop? Hip hop actually could technically be a nice innovation. It is taking essentially PHP, which is what Facebook was built on PHP. And they wrote hip hop, which is more of a compiler to build PHP programs and compile them to C. See what I mean? I know, right? You're totally right. It is right. We're talking a lot. Okay. So I think we need to do this. Wait, no. Increment. Okay. Oh, .div. Okay, so this will divide. All right. So I want to do something different. We need to create a norm. We need to register a buffer. I need to make sure that's the correct way to do it. How do we do this? Register kernel. No, there's a register buffer. I know there is. Register. Where I had it up here. Register. Okay, we need to look it up. When you test a new computer, how to test a computer? What? You mean you want to benchmark it to see how fast it is? There's just do a search for PC benchmarking. Parameter or like buffer. It is essentially it's a parameter. It's essentially a parameter, though it's unchanging. So we want to register as a buffer so that way we can use it in the neural network. Man, with iPatch, we got a whole bunch of W's in there. Get a whole bunch of W's. So register parameter, it might be register parameter. I need to go find it. I had it up here somewhere. Register, where's that at? Register. I saw it. Here we go. I think it's called register buffer. I'm pretty sure. And then what we do, so we go like this. Watch this. Okay. So self dot normalization equals register buffer self dot, wait. Actually, it's got to be like this, something like this. Paste. Self dot register buffer. Okay. How's it going, everyone? So yeah, shout out to Steven from Savon. Hello, Savon. How's it going? We were just chatting earlier this morning. Good to see you. We're gonna make this happen. We're going through we're going to track the clicks and then see if we can predict the future. That's the goal. I think we can do it. I think we can do it by the end of the stream. I think we can make it happen. There's a good man within you, Arthur. Wrestling, and again, you've broken my heart again. What? And I've broken yours? QS10? What are you talking about? What is this? 11 minutes? Miss Steven could build a spaceship in 11 minutes. We might not. That seems like it's a... There's a lot of parts to a spaceship, Savon. There's a lot of... You smart dude. Thank you. Ikuter, thank you for mentioning it. Hey, SAQ 3000. Welcome on in. Good to see you. All right, so register buffer. And we'll say this is the normalization. Yeah. Let's see here. All right. Normalization. And it's going to be a torch.tensor. And it needs to be the width and height. So where do we put that at? We put that somewhere. Where does our window at? Is it in our game? Oh, it's in our game. So we could say game.window. Can we? Can we say that? I think we might be able. Well, .screen. .window. .screen. Okay. I need to be able to see. Where did we have that? So we had it earlier. Oh, we have it right here. Oh, excellent. Oh, it's already right here. We already have it partially the way there. Excellent. Okay. So this right here is what I'm looking for. Perfect. Okay. So let's make that so it's a little bit easier to read on the screen. All right. Excellent. Okay. So this normal, is this how you spell normalization? Let me copy and paste this really quick. Bring this over here. Normalization. Yes, I did spelling correctly. Excellent. We got spelling correct. What's up? We're getting our click predictor going. And I wanted to build it in a way that I've not ever used Pytorch. I've always done a lot of the pre-processing and post-processing. W is spelling. Hey, Kyle, how's it going? Good to see you. Happy Monday. Let's see. Let's bring this back over here. Okay. So we did it. Normalization. Normalization, right? Yeah, that's right. Let me double check. Here's how Google says it's spelled. Yep. Okay, good. Nice. What do you think about agentic AI? It is the future. It's the future. Right now, all the automation systems that exist in enterprise today will get replaced by agentic AI. Happy Monday, Kyle. Good to see you. The Last Attack. Hey, how's it going? Hello, brother. Good to see you. All right, we got a registered buffer. I think, hopefully, I don't know. Let's see here. Let's make sure. So let's search this real quick. Pytorch. Let's see here. The self-registered buffer method in Pytorch used to save tensor as part of the module's persistent state. without making the model parameter in a optimizer will update, right? Because we're not going to update it. There's no gradients. It didn't even calculate anything. It's a constant. Essentially, it's a constant. And we want to be able to use it as a part of our equation when we're running it through our model in the GPU kernel. That's what we want. Mohammed, well, how's it going, Mohammed? Good to see you. Hi. Hello. Happy to have you here. All right, let's see over here. Yeah, I'm an automation engineer, and organization is more inclined in agentic AI. We're on the right path. You were on the right path. Agentic AI is the industry's upside down, though it may take until end of 2026 for businesses to realize the ROI. It is. I could see that. It's still difficult to set it up. You need to have a lot of understanding of how the systems work and how the inputs and outputs work and how you can use it in a way that prevents you from hitting a non-deterministic output, right? You need to lock it in. So you need to use something called tool calling or forced format return with this JSON, like a serialization. I struggle with writing the README file. Hey, we're cooked. Hey, you have to have the AI do it now, right? Exactly. Sivan, exactly. Yes, you got it. You got it, Sivan. They always say there would be ROI, but like they always downplay the time frame. They do, right? There will be ROI. There will be. We promise. Oh, there'll be ROI. Maybe it might take a couple of years. For some companies, it's all about the budget. It is. You got it. Would you like? Okay. I know, right? All right. So we've got our buffer. I really hope this part works. Okay. Can we run it? Can we run it really quick? Let's see here. I want to make sure that this runs. Python main. All right. No crashy. No crashy. Yes, crashy. Okay. So it did not. It's not happy with that. We need to figure out how to do this. Okay. Got some music going there. All right. So my life last 2 years as an AI consultant. It is, right? It'll happen. You'll get the ROI. I promise. I'll promise. Okay. So even though I Googled this and this is not a, so I need help with this. Okay. So we need to be able to parameter. I suppose we could leave it as a constant and then make it a tensor and then just make the tensor and move the tensor to the GPU and then use it directly. We could do something like that, right? Let me do something really quick. I'm anonymous 2025. What is are you talking about the hacker group anonymous? Like, what are you talking about? I learned today that Steven's graphics card was probably more than my car, like 30K. I've used the NVIDIA 30K GPUs. I've used them, and we could lease them. Like, I click a button and turn it on. It's only like, a few dollars per hour. The hacker group, it was? And then it's a hacker group, yeah. What card is it? Just, Kyle is exaggerating. I have a regular consumer card here. It's nothing fancy. It's nothing fancy. Oh, I use some of them A100s. Yeah, there you go. Some of the A100s. That's it. All right. So I need to go over here and look at some things really quick because where is it? It's not here. I'm looking through my source code here. Here we go. Wait. This should copy and paste my stuff here. 1 second. Copy and paste. This is that it? All right. Paste it. All right. Good. Okay. Elgato. Elga. How's it going, Elga? Eddie Legendary. Yo, Eddie Legendary. Good to see you. The Tech Man. Hello. This costs like $1,000 a day. It is. It's very expensive. It is. I mean, hello. All right. 1 second. I'm trying to get this register buffer to work. To fix this, wrap the list in a tensor before registering it. Oh, is that all it was? Is that all my problem was? Or you just need to make it a tensor? I thought I did. Oh, maybe I didn't. Okay. 1 second. Okay. We just grab and paste this really quick. Okay. Here we go. We're making progress now. It's got to be a tensor. Okay. Good. All right. This makes me feel really good. I really hope this works. This will make me feel really happy if this works. Okay. It worked. Okay. All right. So here's our clicks. Okay. So, chords.view. Okay. Got it. We're on our way. chords. Here we go. It will be X. There. Much better. maybe. All right. So I need to double check this. This needs to be fixed. This needs to be the register buffer. So I need to figure out how do you use a registered buffer in your graph. How do you do it? I've never done it before, so we're going to do it today. So the torch type is mismatching when you are trying to assign it to the tensor as a matrix abstraction, right? Yes. Steven, you got the source somewhere on GitHub? Yes. Sure, it is. It's on our Discord. So let me see. I will be able to maybe find it on Discord 1 second. I do believe it is here in free resources. Here we go. All right, I'll try to paste this into the chat here. Hello, everyone. Torch has no graph, just the 2 by X. Yeah, they call it a graph because you can break it. Thank you for the likes, you guys. I appreciate it. All right, so here you go. Savan, there you go. I sent you the link. Dynamic graphs are easy. That's basically what we're doing is we need an unbroken graph, which is something that allows you to compile it and export a Pytorch file, right? A Pytorch file. So I want an unbroken graph. Otherwise, you can do like some pre-processing and post-processing and other things that are outside of the Pytorch library that are not serializable into sort of a way to export the model, which then can be imported into other languages like Rust and C++. So that's the idea. Thanks for the link. Yeah, you're welcome. It won't have all of the updates because we just have some of the things, but it's pretty close. No need to do anything special. It should infer the parameters when compiling. Yes, we need to be able to reference the name of it here. We gotta reference the name here. So that's what we gotta do. So I've got the docs around here. So unless you need the parameter explicitly, I do. I need the parameter explicitly because it is a constant value of the screen width and height, which will be used to normalizing the inputs of the clicks into a number between 0 and 1. Right? So we need to normalize it or like move everything into the same space. And then we denormalize it when we decode it back into the XY coordinates from the output. And that's what we're doing. You already got your admission in the college. So many more exams. Let's go. That's great to hear. I knew it. Eddie Legendary. I knew you were going to say that. I knew it. I just knew it. Maybe in the forward pass, we could do that too. Because that's basically what we're doing an encoder. And internally, it keeps the structure of a graph. So no matter what functions you execute, you can do them in different patterns. So I'm trying to do it in the most PyTorch possible, the most PyTorch recommended way. PyTorch native. That's what we're doing. Oh, the to-dos are great. I know. Fix this. Right? It says fix this right here. Fix this in the exclamation points. Yeah. We got to do it. So Gemini says the unbroken graph allows the torch optimizer magic to happen. Yeah, exactly. You got it, Savan. You got it. All the mods here. Yeah, we got all the mods. All the mods are here. All right, let me jump over to here we go. All right, I need to make sure that everything is in where I want it to be. Okay. Where was that at? Okay. Torch tensor. Yep. Okay. Where is this graph at? Normalization, flatten. Where I'm looking at some docs here. I need to find. So we registered the buffer. How do we use the registered buffer? That's what I want to know. All right. Oh, we just straight up refer to it as self dot. So if that's the case, self dot normalization, just like that. Easy done. X dot view -1, 2. And then, so this should work right here. I think that's it. I think we did it. Let's hope it works. The parameters in the forward pass unless you like absolutely adamant on the being baked into the model. Yeah, well, that's a good point. We kind of, if the screen size changes, then the model's out the door, right? So, but that's fine. It's fine for now. You predict it works, Kyle? I predict it works too. I think it will. The optimizer should be essentially zero cost if you pass it a value forward. Okay, so you're probably right. That's the way I would traditionally do it. I would traditionally take that approach. For now, let's see. Do we have game? We do have game. Okay, so we have the game here. And then I want to see print. Print. Yeah, I want to print this out. Print this. F. Okay. I want the game width and height. All right, let's make sure that we grab this here. I want to make sure this looks right. Let's see. Game width and height. Excellent. Width and height. Okay, so I want to make sure to see that being printed, and it should look good. Yep, okay, good. Excellent. We see here on the screen. Looks good. And we have our MPS hardware accelerator as well. We're good to go. All right, so I should see no crashes. Wait, did it just crash? Did that? It did. Oh, darn. Okay. We'll figure it out. We'll figure it out. We're almost there. It did, Kyle, so good news. It worked for the part that we wanted it to work for. So, progress. We're making progress. You talking about Torva? We're talking about Torva. Oh, Torva. Right, Torva. Where's Torva at? Let's see here. You like to code most Pytorch? Python AI would do it that way. Got it. Okay. You're usually not really supposed to mess with things than the parameters. See, that's a really good point. What I'm also doing, so I have a whole bunch of Google notebooks, right? LM notebooks, right? Google notebooks that have been going on some of these tutorials, and I'm trying to learn more of Pytorch. I want to be able to have like a full like expertise on every single one of these functions and when to use them. Because usually I just write the algorithms myself. And I know what to do. I know what I want my input to be and my output to be. I don't understand when to use, like, I do know, like, there's a V2 compose. So I have been using this V2. So I've been using V2 here, which is the updated version. That's what we're doing. Although, compose transform. Yeah, for the transform. That's what I've been doing. The AI is better than me? Yes. It should crash. It crashes instantly. Yeah, it does. That's what's happening. Okay, so you're doing it slightly weird from learning. Makes sense? Okay. Yep, you got exactly. We're doing it slightly weird on purpose for learning and purposes. For learning. Okay. Okay, I think this good. I think we did that good. That looks good. Do we need to... I don't think we need to flatten it because our input's already flat, right? Our input's already flat. So we got our before. What did that look like before here? Is it already flat? What is this? That is messed up. That is not... Wait, 2, 4, 6, 8. Okay. Oh, before. Perfect. Okay. Yes. Yes, yes, yes. All right, that looks good right there. I like that. Okay. So we're looking good. We're looking good. Was there an after? There was not an after because there was a bug here. We need to fix this. Okay. We got to fix that. I need to go. Sorry. Hey, all good, Eddie Legendary. It's great to have you here for a bit. It was good to have you here for a bit. Okay, so let's jump back over here. We know that the problem is occurring right here. So the encoder, is it still crashing on the encoder? Okay, so that means it's crashing here. It looks like right here. Let me go and see if we can do it differently. Let's see if we're gonna mess around with this here. Can we do it like this? Normalization, like that. Looks good there. And we want to x equals, okay, 1 second. X.view, divide by normalization, right here, reshape. Perfect. It needs to go inside the lambda though. I think it needs to go inside here, like this. Okay. All right, 1 second. Pop, like that. Okay. All right, that looks good. Let me make it look pretty really quick so I can see this a little bit better. Okay. So that, I believe, we should be good with. I think that probably will work, although I'm not sure about this. Okay. I'm just double checking. Let's try it out. Let's see if it works. Okay. Here we go. Click, 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 click. All right, still problem. Shape -1, 2 is invalid for input size of 1 because it is an input size of 1. It is 1. X is 1. Okay. Let's see here. All right. 1 second. Maybe the input side, maybe we're doing something weird. Okay, so the before self features forward. Where is this? Oh, so model. Where's our model at? In predictor is going to be predictor predictions. Here we go, and the predictor's here. Here we go. Okay, so let's try it like this. I don't think that's right, but we'll try. We'll try it because it's usually supposed to be a batch. Okay, yeah, that's what I thought. Okay, so that's not the problem. That is not the problem. Hey, Gun, how's it going? Hello, Steven. Pytorch, yeah, let's go, Pytorch. You're better than AI. Sometimes. Usually the AI will do a pretty good job being fuzzily accurate. It won't get you all the best possible optimizations. That's the magic. You got it. That's the magic. All right, let's see here. I am interested in, let's see here. Okay. All right. What we could do is we could break this up and make it into something different. So that way we don't have to, let's see here. Let's see. Oh, if your input is exactly, okay. And it should be. So our input, let me debug this really quick. Debug this really quick. So when we do this, I want to print features. Let's do print features. F features is features. Excellent. All right, let's see what that looks like. Oh, we're already doing it. We don't need to do that. What am I thinking? Okay. So that would mean, all right, so this looks fine. That's our input features. This should be fine right here. Hopefully you don't promoted your repo here. Hey, no worries. All good. Hey, also, Sivan, if you post a link, they usually get modded, auto-modded away. It won't. Only mods can post links, I think. So Sivan, post it to Discord. If you want to post it over the Discord, then it will show up. It's guaranteed to show up if you post it on Discord. And you just subscribe to. Nice. I'm new. You're new. You subscribed. Excellent. Christiana. Hey, Christiana, thank you for your subscription. Welcome on in. You know, Steven just found out. What'd you find out? Macros and functions in Excel? Hey, now you're going. You're in the future now. You're in the future. Pandas and llamas, thank you for your subscription. Or thank you for following. Oh, following. All right. So you're probably over there on the purple platform is what you got over there. Following on the purple. Automation tab in the main language is TypeScript. Nice. Microsoft finally got rid of Visual Basic. Yeah, Visual Basic. Will do. Sounds good. Excellent. Yeah, SAQ 3000, you can post links because you're a mod. Right? You're a mod. You can do that. Oh, right. I have to join the Discord. Yeah, join the Discord. Thank you, Kyle, for posting the link to the Discord. Thank you. Okay, so I've got my right input. That's the correct input. Now, this is the problem right here is the view because X is just one parameter. It's just one parameter. How's it going to work? How are we going to do this? I don't know. The only thing I can think, my intuition is to say, let's not use compose. Let's do something different. Although it's so nice to have a encoder that's all in one, isn't it? It's so nice to have an encoder that's all in one and predefined up front. Isn't that nice? I really want it to work. The problem is this. It's because it's only giving us one parameter and we need two, because we can't normalize. Each number is gonna be different unless the game width and height is exactly the same dimension, right? So it's a square, not a rectangle. Then it will be fine. So I think what we need to do is not do the encoder, which is annoying. It's really annoying. Darn it. I don't know how else to do this. Let's see if we can read more details on this really quick. Okay. Handle different inputs automatically instead of view. Reshape. Okay. So we might want to do reshape instead of view. That won't work though because we're in this compose section. So how do we deal with such a scenario? I suppose we can just not, I don't know. Like, it's in CPU. So what I really want to be able to do is get this all in GPU world. I want this all in GPU world, but it's not. It's not all in GPU world. It seems like that's the only, I know it'll work if we put it into CPU world, but I want to make it go in GPU world. So let's see here. All right. What we're going to do is we're not going to use compose. We won't use an encoder. Instead, we are going to make a tensor. So this will be, how do we do it? I suppose we could, how? Hey, bro, I'm Ashina. Oh, wait, Ashinsa. Hey, Ashinsa, how's it going? Hey, Drawing Brothers, good to see you. Happy Monday. We're getting to go here on our Pytorch. We've got our AI that's going to learn how to predict the future with the user clicks. And we're getting stuck on my early optimization problem. I'm just trying to get everything up and running into the accelerator up front. And I know we could get it to work with the CPU and optimize it later. So I think that's what we really need to do. Let's do that. Let's go ahead and do that. Okay. So so we can't do an encoder here, unfortunately. So we're gonna have to comment this out. We'll just do this. Comment it out. Okay. Where are you from? United States, Seattle. How old are you, bro? Older than the Primogen. I'm older than the Primogen. If you know who the Primogen is, I'm older than the Primogen. What is the project? What is the goal? We want the AI to predict where the user is going to click next. So we are going to capture clicks from the user. Click, 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 click. Right? We're going to click a whole bunch. Okay, here. Let's comment that out. Bring this back over here. Now this won't crash because I've commented out the bad code. So we got all these clicks, right? We've got all these clicks. And I'm going to have the AI predict where the user is going to click next. So you saw how I kind of I'm clicking in a circle here. The AI should be able to learn that pattern. Or if I click back and forth, right? If I do sort of like an oscillating thing like that, the AI will eventually learn that I'm clicking back and forth. So that's the problem. That's the challenge. That's what we're going to do. That's what we're going to do. Okay, let's go ahead and close that. And bring this back over here. All right, so instead of doing a separate encoder, we could do def encoder like this, features, and then we will execute the encoder inside the forward function. So that's what we'll do. And then we'll have a def decoder like this. And we will put it down here like that. I think it's fine. And we'll say pass for now. Okay. And then self.encoder will be like that. And it'll be able to do it just fine. Perfectly fine, just like that. Water with socks, warm socks. Got the warm socks. You got it. Warm socks, you guys, are the greatest. I really like them. No way, that means you are better than, I mean, the drawing, right? We're just two people who've been on a very similar journey in Silicon Valley over the years. In Silicon Valley, in the startup scene, we've been through it. I would say very similar in San Francisco, right, and in Silicon Valley. It was a lot of fun. It was a great couple of decades. Let's just say that it was a great couple of decades. What are the features? The X and Y coordinates. Mindset. How is it going? Mindset. The features. Did you work at Netflix? No, I worked at other various startups, and then I've got my own, right? I've got my own startup, and we're doing very good. The Primogen worked at Netflix, though. Michael worked at Netflix. Hey, what different stuff you like? AI stuff? Yeah. More in the backend code? They do different stuff. That is true. They do more backend and traditional stuff over there. You got it. I like your stream, man. What do you do? Hey, Paga. Thank you for saying that, Paga. We are into software engineering. I've got my own company. We've got over 1 billion connected devices. We're doing very good. We're growing. We've got a open role for a senior software AI engineer, and we're programming AI today. That's what we're doing. We're programming AI. Not the similar journey. You were doing coding since 14. That's true. That is true. Yep. We got started at different ages. Let's see here. All right. So I want to say features equals. We need to turn it into a torch. So we need to do this here. We can convert it into a torch. Features. There are all features everywhere. All right. So features is being converted to a torch. Tensor to a tensor is what I mean. He's the CEO. Well, almost. You got one letter right. So I've got a co-founder, Todd Green, who is the CEO, and I'm the CTO. We've started PubNub together many years ago, when we got old. We got old after many years of success. We've done a lot of fun things. And we're not done yet. There's still a lot more to go. Okay. So we need to features equals, I think we need to go over here. We don't need to reshape it though. I do want to divide it by the normal. Maybe we could. All right, so let's say features.reshape. We're going to try this. And it will be -1, 2, like we were doing before. Like that. So it's going through a pipeline. We don't have a broken graph technically, right? Because we're still going in the forward path and we're just calling it encoder. So we should be good. Oh, how do I come to Valley? Go to San Francisco, to Silicon Valley? You meant work at FANG, right? Facebook, Apple, Netflix, and Google. What's the other A? I forgot. What's the other A in FANG? You've got 2 A's in FANG. It'll be obvious to be like Alphabet. Is it Alphabet? I don't know if it's Alphabet or not. I thought G was for Google. But Google and Alphabet, they're the same thing. What is the other A? So you've got 2 A's in FANG. Drawing Brothers, what is that? Amazon. Oh, right. Thank you. Of course. I should know that. Being that Amazon is just like right there. Like I'm here in Seattle, and like Amazon's just up the street. So I should have known. Why did I not think that? It's like the one that I should have known. I feel silly about that. Okay. Reshape. Let's see. What else are we going to do? We need to divide it now. So let's do features equals features divided by the normal. All right. Self dot norm. There we go. Wait, we got to do division. There we go. Self division. Excellent. You applied to Facebook once and got like a 3rd interview. Nice, Kyle. That's progress. So the answer was Amazon. It was Amazon. You got it right. Okay, and then we need to reshape it back to -1, I think. Yeah, okay. Features equals features dot reshape -1. Okay. It would be nice to be able to print it to understand what it looks like each of these phases. So let's print out features every single step of the way. Print F features. See what that looks like every step of the way. So let's look at this. Blah, blah, blah. Perfect. All right. Let's see what happens when we do that. Okay, so we don't need this anymore. Let's get rid of this. Our reference code. Looks good now. How do I work there? Oh, guide you. Well, what I've heard is nowadays it is challenging to get a job, especially at anywhere where they've got a huge amount of applicants. You have to cut through the noise somehow. What I've found and I've heard is that you need to reach out to other people who work there and start figuring out ways to get the foot in the door. So you need to connect with people. So you have to go around the front door, basically. So you've got the front door. The front door is the resume submission application to a job listing online, right? That's the front door. You need to go into a side door. The side doors are locked. So you need to find someone with a key. Someone with a key is someone who works there. So there you go. There's one extra little side step. You could also start building specific applications and projects and even products that you deploy into production and get users that is using the technology for the company that you are currently trying to apply for. Just build something and make them buy it from you later. There you go, Kyle. That's the right way to go. Hello, hey, how's it going? Ujwal Balian, how's it going? Good to see you. All right, so let's see what that looks like. Yeah, shall we? Let's see what that looks like. Features before, features after. All right, this should work fine. This should perfectly work fine. I wanted to use the new fancy compose. I really did. I wanted to use it. At least we have this normalizer here. So we can use this normalization layer for the encoding and decoding. We could do the same thing. I do believe we can do that. So this would just be the exact opposite here, except for we don't need it to be a tensor. So we do want to reshape? Yeah, I think we just don't need this for the decode layer. And then we can reshape it. And then we multiply instead of divide. Perfect. That should do it. This is what you're stuck on as well. Not fun. Job search is hard. Yep, everyone's going to the front door. So if you can get into the side door that's locked, you might be good. The background music, more like Halloween at some moment. Was it? It seems appropriate since we were talking about jobs. Okay. Let's see if that works. Okay. Let's do a click. Click. Okay, perfect. Okay. Features. The full array. Reshaped. All right. Yep, reshaped. There we go. Perfect. Right? Because now it's X and Y, right? So this should be a 1. Right? So let's go over here. 179. Wait, hold on a second. Oh, wait. Right. Where'd that go? 1, 2, 3. Looks good to me. And then the label. I didn't print out okay. We also need to transform the labels. We need to normalize them as well. I know a CTO. He's great. All right, Kyle, thank you. I'm pretty sure. You know what? I just assumed you meant me, but it could have been someone else. Steven, can data be sold and get money there? Yeah. User experience plus sucks. Probably. I think so. All right, let's see. Click. Wait, I'm gonna just click. So it's all the same. Okay, excellent. It's normalized. Here you go. Features after. After is none. Oh, because I forgot to return it. I forgot to return. But this is where it says correct. So this is normalized. Good. Very good. Input. Yes. Looks good. All right. So that's the features and the labels. Perfect. Okay. All right, you guys. It's working. We're making our way. Let's see here. We need to return features. There we go. Perfect. Okay, so we did it. We've got our graph. It's looking good. So there's an encoder, decoder, and then we want to return features. I do believe this should work fine. And that's for, wait a second. I suppose we could, for the training data, I think it's fine. We'll just keep going. Bioengineered mushroom-based footwear. Oh, yeah, with smart warming? That would be pretty neat. You're onto something. If you could actually get that to work and it would be washer machine friendly, you'd have something there. What is OSINT, open source intelligence data? I'm not familiar with that. What is that? I'm not familiar with it. Can you sell data breaches or inform clients then get paid? Yes, you can. That works too. That's another way to do it. You got it, Drawing Brothers. Okay, so let's make sure that looks good over here. Okay. Click. All right, before and after. Yes, it's a tensor that has been normalized. All right, we did it. We got our input data. That only took 2 streams. It only took 2 streams for us to get that. You have a question? Karmu, what is your question? What question do you have there? What are you interested in asking? All right, so we also have to normalize the labels, which we should be able to do just on the encoder part when we're doing the training. I mean, we're not using a data loader because we're doing reinforcement learning and it's all being generated in real time. Let's see if you can answer correctly. Where do women have the most? Well, Carmu, I don't know about that question, and I can't really. I don't know. I don't know what the correct answer is, and we won't be guessing. We won't be guessing right now. We won't be guessing that question. All right. Thank you for asking, though, I suppose. Okay. The answer is Africa. Okay. That is definitely not what I was thinking. I was thinking something else. Thank you for clarifying. Thank you for clarifying. Okay. So we can do this, the encoders on the forward. All right. So that's the encoding. Now we need to do more. We need to run it through the model. So self.model. And then our model, wait, hold on a second. I do believe we had it here. Perfect. Okay. So that's the model. We should be able to run it through the model features and get the output. Output equals that. All right. So that should also work. That should work perfectly fine without any problems, I believe. So let's make sure that works as well. All right. Looks good. All right. Let's make it very big. This should be near close to 1. Yes, it is. 0.999. Perfect. 0.99. Can we make it even closer to 0.9? Yep. Not quite there. All right. Perfect. That should be very close. Yep. 0.99. Isn't that good? All right. Excellent. I think the intention is the biggest factor of success. You're going to be, if you want to be a millionaire, you won't make the right moves if you focus on solving your users' problems, saving them from time you win. Yes, Cal, you got it. You've got the right answer there. You've got it exactly. You want to focus on making the thing easy because that's why they want to pay you money. If you make it hard and complex, you still might solve their problems that are still hard and complex. You're just trying to reduce the complexity. That's what you're trying to do. That's what you got to do. Reduce the complexity. All right. Encode model. Okay. I'll put in the model. And then we want to say decode, right? Oh, if we do the decode, then we never ever have to modder with the labels. Oh, decoded. I thought this through previously. Self.decode. Here we go, you guys. Output. Hey, we're on to something now. Return decode. Decoded. Here we go. Features, output, decoded the output. Hey, now we're on to something. All right, so I want to print the output. Output. Here we go. Output. And then also the decoded. Let's do that as well. There we go. Okay. Let's see if everything looks proper now. Let's see if it looks proper. Is it legal since you work under an organization? Probably. Complexity reduction, isn't it? And here's the great part, Kyle. This is amazing. There's so much complexity existing today, and the opportunity to optimize is mostly boundless. It's nearly boundless at this point. So the more you can optimize for simplicity and make it easy, the easy button, you win. That's how you win, you guys. Make it easy. All right, click. Okay, decode because I think I called it decoder. Okay. Fixing issues, got them good. We're good to go. All right. Oh, another issue. None-type object is not callable because why? Where did that happen at? Feature. Oh, yeah. All right. Output probably. Let's just do this really quick. Output. Here. We will copy this. S/features output /G go. Excellent. Perfect. Okay. Although we got to go this one right here. All right. Perfect. Decoder output features looks good. Features. Okay. Decoded equals decoder. All right. So where was the problem? Do we need to reshape it? Do we? I think we do. I think we have to do that. I think we do. Something make it complex so they can also sell consulting and professional services via partner. That's another way to do it. You're right. That's another way to do it. Microsoft does that. I think Google does a little bit of that. Oracle does that a lot, right? Isn't that like a huge Oracle thing? Subtractive engineering. Kyle, you are the future engineer. You are at the top. You know what you're talking about. Subtractive engineering. We got to make it better, faster, cheaper, easier. You got it. With AI, it is. I mean, they could, right? Especially they could make it complex. Thank you for the likes, you guys. Thank you. Is that you, Kyle? I don't know. I see little floating heart icons go over there. A lot of time optimization makes more complex stuff. It does, right? You could. So you want to do reduction. You want to do reduction. Subtractive. Optimize and subtract. Here we go. Two features merge and become one. And the user has less steps and the same outcome. Yeah, you're right. Hey, Rawet, what are we doing? We've got an AI that's going to track clicks and predict the next click from the user. That's what we're doing right now. Also, we have some sort of bug, and I think it's around here somewhere. So we're going to try to fix that. We're going to see if we can fix that. Click, click, click. So here's the clicker. Although there, it just crashed. Where is that? Output, decoded output. None type. Output. Did we name our variables wrong? On line 148. That looks fine to me. That looks perfectly fine to me. Where is that at? Okay. Let's see here. Random guy are saying a whole bunch of text right now. Now we're thinking like CTOs. You got it. You got it, Kyle. You got it. Random guy, how's it going? Hello. Hello, random guy. Okay. So where is my problem? 148? 148 right here. It doesn't like that. Why not? Is it because it's not? It's right there. I've defined it. I've defined it perfectly fine. Self is spelled correctly. Output is spelled correctly. Self. Isn't it? We've got self, yeah. Output, self. We're using self just fine. None-type object is not callable, which is what we're doing right here. We're calling. Is this the correct? That looks fine. All right, let's just try it again. Let's see here. All right, let's see where it crashes. Click, 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 click. Okay. Output equals tan h backward gradient. All right, good. We need to decode this now, so that way the output on the other side looks exactly like the labels are. That's what we got to do. Brother studying software engineering in 2026 from beginning. Good or bad? Good, maybe. I don't know. I think it's good. Is this coding stream? Yeah, you are. This is right. Plush. This is coding stream. You got it. What are we coding? So here, check this out. I will run it again. So we've got a program here that tracks the user's clicks, and then it's going to crash right here. There it goes. It crashed. And then we're going to use that as input data to train the AI. As the user clicks, the AI will learn more and more, and will learn where the user's going to click next. So we're going to see how good we get to it. We're going to figure out if we can make it. How much math is required for being the best? Well, you probably need all the math. You said the best, right? So all the math. Though you don't need that much math if you want to be close to the best. You can be around that. You'll be fine. Is it all right to debug codes using AI, or is it bad? It's the future. If you're using AI today to write and debug your code, you're doing it the proper way going forward. The industry standard going forward will be to write code using AI. For me right now, I think there's a problem though. You might atrophy, which I've found after using AIs. You'll atrophy, you'll lose your ability to write code from scratch. And I've turned off all AI right now, other than maybe like searching for like documentation and stuff like that, because I want to hand type this all myself. So that way I don't atrophy. What topics are required for math? I think mostly just calculus. I think that's the only one. Maybe some regression, right? Linear regression, things like that. I speak English. Shorts, I speak English. That's about it. Will AI take over the tech industry and jobs? It seems like it's gonna, because just in 2024, the AIs that were code generators were able to solve 10% of the challenges, the coding challenges, the problems in a software benchmark, a software engineering benchmark. Today, they can solve 80%. Isn't that amazing? 80%. And that's just after a few, a little more than a year. So we're basically, are we cooked? Yes. In that case, do you think AI is going to take away jobs. It kind of already has. Japneet, it has already, right? Plush, are you coding ChatGPT? We are coding just regular AI today. We're doing regular AI. It's not bad to be able to write code from scratch. I think it's necessary for you to be able to compete. And when I mean compete, I mean compare with the AI output. You need to be able to read it and understand it and see when something is wrong. And if you don't do exercises regularly, I think you might. Although this could just be me and my old person, right? I'm an old person. So I'm just saying, you must write code from hand. If you do it any other way, you're doing it wrong, right? No, we're not saying that, because the future is having the AI code for you. Atrophy is after my life, but you have to keep going. Aren't you scared? No, not really. I think we're fine. There's still a whole bunch of innovation that needs to happen. We're decades behind. We're decades. We've got a lot to go. Drawing Brothers, see ya. All right, sounds good. It's amazing when you're fired from your job because AI took it. Well, it seems like a problem. It's a little bit of a problem, yeah. Is this on Twitch? Yeah, we are also on Twitch. You got it, the purple platform. No offense, but how do you know this letter does this and that does that? Just practice. You have to memorize it. You have to feel the pain. The pain is you learning. You have to go through the problems of debugging. Right? See the screen right here? You see the screen with all these crazy numbers and stuff like that? That's pain. You have to figure out how to understand that. And then you have to write code to be able to fix the problem. And then when you do that, you memorize. That's the pain. You got it. That's the pain. That's the memory. The more experience you have, the better your coding. Yep, you got it, agent. You got it. SAQ 3000, thank you for hanging out. Do you cope with the AI being better every day and that can take away your job? Well, you just need to use AI. Those who are not using AI will get replaced by people who can use AI. No pain, no gain. You got it. You got it, Mega Animations. You got it. Let's see. If I log into Discord, is there a live chat as well? Yes, there is. So it's here on Discord. So resources. Oh, Savon, hey, you made it in. Nice, Savon. You made it in Discord. Nice. Good to have you here. Yeah, so feel free to chat wherever you want. Chat it up in Discord. You have the best live stream on YouTube, bro. Thank you, Carmu. Thank you. We're making it happen. How do you start using AI, like complete guide and prerequisites? How long did it take you? AI took me quite a while. I didn't have a lot of the expertise up front, so I had to take a few years to practice it. What's this project? The project is we're getting an AI that is going to track the user clicks. So you see here, click, click, click. See the clicks on the screen? We'll track the user clicks and we'll have the AI learn those clicks and predict the next click. That's what we're doing. That's what we're doing. By the end of the stream, we will have it working. Although there's a lot of chat and I'm not being able to keep up. I can't keep up with the chat. I do have to focus here a little bit on this in order to, otherwise we won't make it. All right, so we know there is a problem here. The decoder, there's a problem. What if we just return the output? Let's see here. Let's just return the output straight up. Let's see if that's going to... Oh, no, there's another problem somewhere. Oh, good. Okay. Where is the problem then? Features. It prints this, right? It does this. So, oh, in the model. Okay, so it might be here. It might be here. Okay. I think that might be the problem. You guys use YouTube and Google? Get your goals. What's the language? Python. We're using Python. Sorry, there's too many chat messages. Sorry, I won't. Can't keep up. I'm not able to keep up. How much time does it require to learn AI from ML and Scratch to make models which can detect atmosphere or other things? So here's the deal. If you want to do it by hand, it might take a little while because I've been doing this for years and I'm still figuring things out. I'm still figuring it out. Although I haven't been full time on it, so if you spend most of your time on the AI, you should be fine. Maybe a few months. I think so. I think you could probably achieve your objective in a day or two using AI to help write the code for you. I can use help edit a beginner AI guide, Steven. If you prefer, just let me know and provide details. That sounds great. Kyle, that sounds great. To return output on decoder. Let's see here. To return... oh, yes. You got it. You're right there. San, San Pagara, thank you for following. Thank you for welcome in. This channel is all about software engineering. We do AI. We're gonna verticalize on AI. We'll be using Pytorch, Python, and we'll be building all sorts of AI projects going forward. And a whole bunch of things. Like 6 months? Yeah, I think so. About 6 months. 6 months sounds about right to me. Okay. So yeah, you're right. There's two, because I'm trying to figure out where the error is. And I think this is where I said model. That should also work just fine. That's not working fine. So let's do this. We're gonna comment some things out here really quick, and we're gonna make sure that we get back to something that works here really quick. Really quick. I just came back from YouTube. Nice, San Paglia. Thank you for following. Thank you so much. All right. So click. Okay. So there's another problem here. Return decoded. Okay. Obviously. Okay. There we go. La la la. Okay. Here we go. Click. Okay, we're clicking. It's working. Good. Okay. Let's bring this back. See if that works. That should work perfectly fine. I don't see any reason why that should not work, unless I misspelled something. Okay, good. Okay. Good. Output looking good. All right. So everything right here works. And then, how are you feeling motivated to do this? It's exciting. It's neat. I don't know. I think it's neat. Like Trong movie. Wait, Trong movie? What do you mean? Katharuika? What do you mean? Oh, like Trong movie. What's that mean? Tron? Or what is this Trong movie? Can you post your GitHub? Sure. It's here. So let's see 1 second. I will help you with that. Let's I'll post it on Discord. I'll post it over here on Discord. So GitHub, here we go, copy paste. I'm gonna put it in the free resources link. Here we go. This is the GitHub for Steven. There you go. On Discord. There you go, on Discord. Okay. Tron the remake. Oh, right. All right, Tron the remake. I remember that. That was great. It was a good remake. It was really good. Savon, that was a great movie. I loved it. What kind of software you use while learning? Mostly the browser, right? So we've got our browser here, and there's a whole bunch of tutorials. So you can see here we've got some tutorials, and I read through the tutorials, and I practiced. And you practiced. And that's what it is. It was, let's see here, as in another dimension. Oh, a whole other dimension. It was a movie about a guy who created a video game and got lost inside it. That's right. He created the game. The computer absorbed all of his person. Absorbed all the person. I watched the original, and I'm old. Me too. We're all together. Is this Arch Linux? San, this is Darwin. This is Darwin, right? So uname -a. There you go. Darwin. Boom. Right there. I don't know if you could read that on the screen, but it says Darwin. It says Darwin. Okay. Hopefully no interference here. Oh, good. Just playing. No interference. We're good to go. Trong movie like big AI. Oh, I don't know what that is. I'm not familiar. Okay, did that work? Yes, that worked. Okay. So our decode, is that going to work? Let's try this. So this is where we had the error. Click. Okay. Good. All right, we can fix this. We can fix this. So, encoder, decoder, self, output. Honestly, that seems like it should work perfectly fine. What if we call def a whole bunch of D's? We just name it something different. Let's try that. Let's just name it something different. Okay. Oh, wait. Hello, sir. How's it going? Welcome on in. DDD. All right. Let's see if that works. Inheritance, not interference. Oh, inheritance. It might be. It might have actually figured out what the problem is. It is. You were right. You were absolutely right. Just playing. How did you know? How did you know? How did you know? Just playing? Wait, let's double check. You were right. Okay, I'm going to be right back. 1 second. You figured it out. All right. Good job, Justin. Or just playing. Thank you. You figured it out. You like learning Python language? Nice. Darwin's the best fitting game for an OS. Fitting name? Yeah, it's a really good name. Living grandchild of Berkeley software distribution. The good old Berkeley. There's still a lot of Berkeley software out there. A lot is used in the industry everywhere. Also, I said above in the chat. What'd you say? What did you say? I missed it. Let's see. Who was it? Garu? Let me see. Where are you at? I might have missed it. Sometimes it doesn't come through. I don't think the method is calling, or I guess it's the problem. Inherit. You did. You called it earlier, and I just missed your chat. There's too much. Chat's going by too fast. It was going by too fast. I've got a chat aggregator. You were right though. Thank you, Garu. Thank you. I missed it. If I had just read chat earlier, sir, why don't you create your own AI OS? We could. All right, so we need to call it something other than decoder, because decoder is getting overwritten by the inheritance. What if we just call it decode? Let's just try to call it decode. Boop, decode. Let's see if that works. Is that a problem? It might not be, and it is fine now. It's fine. All right. We were doing it right all along. Isn't that great? Okay. Decoded. Now, return decoded. There we go. We just created the model, and we should be able to easily start training it, I think. Hey, Republic. Hey, Steven, you mentioned that you didn't go to university. I did go to university. I just dropped out. How did you learn algorithms on your own? Well, the university still didn't teach me the algorithms. I still self-learning. I even wrote my own algorithms. I walked around. I had my own algorithm book with pen and paper. I did it with pen and paper. Quantified Quantum, how's it going? Good to see you. Happy Monday. I'm glad you made it in. Vroom. Neva says vroom. Vroom. Sir, what is your skill set? Software engineering, distributed computing on a global scale. I've got a company called PubNub. It's this company right here. Let's see here. We are the market-leading platform for connectivity and communication. We've got a bunch of companies using our technology for delivery, for gaming, for sports and media, for collaboration, multiplayer games, and IoT. And we have over 1 billion connected devices, and we've got an API that powers this. It makes it really easy. You can select your language. Every language, you support every language, and you just click the send button. And data will come through. And that's it. That's what we do. Click the send publish button, boom, data comes through. No matter where you are on the internet, no matter what your IP address is, as long as you've got a WAN uplink, you will be able to receive that data serialized and deserialized in about around 30 milliseconds or less. We've got a sort of a distributed network for that. And I wrote all of that in C, and now we are replacing it with Rust, and we're making everything fast and smooth. My bad, heard something else? Oh, I know, right? Yeah. That usually happens. Yeah. So here, it's this right here. Let's see if I zoom in on that. Right there. Here you go. PubNub. That's it. Sir, any day used to distribute systems? Because I never distributed computer or program. Is there any day today used to distribute? Yeah, my company. We have our software distributed across all of Amazon's regions. Your user will connect with a phone or a computer, unbeknownst to you, or TV, or a smartphone, or a doorbell, or a door lock. PubNub sounds like it does. I know, Justin. I know. That's still a problem today. It's been a problem for, well, I mean, I don't know if it's a problem. It's just a matter of consequence is what it is. That's just what it is. Besides Darwin. Oh, FreeBSD or NetBSD. Yeah. I remember that. I've used FreeBSD. I haven't used NetBSD. I always email this company when they use your technology. I mean, do they letting you when they use it? Wait, what? I always wonder, do these companies email you when they use your... Yeah, we'll email you. Oh, don't worry, we'll email you. You could turn that off, though. Oh, speaking of Rust, did you employ the job linker I talked about? Did I? The object linker. Oh, yes, we did. So we're using a faster linker. now for our latest Rust builds. We're using the faster. We're not using, there's a different one, but we're using the native default latest modern version. That's the LLDB linker, I think. Pub is public, right? It is pub. It's what is nub? Sub. So it's one letter different. So it's like publish, subscribe. That domain was taken. Pub sub was taken. So what I did instead, hey, Kaya, thank you for your subscription. Welcome on in. So yeah, thank you. Rust is dominating with its speed. You're right. It is. It sure is. It is absolutely dominating with its speed. All right. We're back into it. We're back into it, everyone. We're back into it. We made it happen. We are figuring things out. PubSub was better. I know that would have been great if I could have had the domain name for PubSub. However, I was late to the game. Even back in the 2000s, I was late. I was late back then. So I found one letter difference, and if you Google for it, you will only find my company. So it was an SEO optimization effort. And now all the AIs do as well. Do you publish these codes? Yes, I do. Yes, I do. Let's update git status, git commit -am fixed forward pass with encoding and decoding. We did it. And then we need some party poppers in there. There we go. Party popper. Pop. Yes, party popper. Copy, please. Copy it. Party poppers. All right, excellent. All right. Done. Push main done. Okay. And it is here on our free section on our Discord. It's on our Discord. So if you click that, and the code is there for you if you want to see it. Hear me out. Someone connects from Pubnub on Antarctica. It works. We've had people connect on Antarctica before. We have. It works. It's where would they connect to? They might connect to US West 1. It's where I think they might connect to. Potentially. I'm thinking. Or Mumbai. They might connect to Mumbai. Or I think of those. I think that might be it. Yeah. Pubnub lore. What was the early Pubnub like? Well, it was a game-focused company. We wanted to build multiplayer APIs. So we wanted to make it easy. Also, you've probably heard about the button where you click and a car comes to you. You probably heard about that? Where you click a button and a car comes to pick you up. There were no push notification technologies back then. And there were no really good, there was no Uber and there was no Lyft. And so there are things like Zimride, and we needed to create a way to send data back and forth between two devices on the internet, like a mobile phone. So there you go. I find it remarkable that Rust is performant as C, Pubnub middleware rewrite, and the syntax is preferable and is a bit more high level, right? Isn't it, Savan, right? Savan, it's amazing. It's great. Every time we deploy, it's better. Yes, location-based services. You got it. And so that's what we did. You guys. That's exactly what we did. And it's been 14 years. So we've done pretty good. I think we're doing good, you guys. I think we're doing very good. Excellent. Yes. All right. Yo, read mine too. Oh, Dubba, what'd you say? Do you have an idea for a website? I'm looking for a tech startup idea that is actually great value. That sounds great to me. Yes, with Pubnub. Yeah, there you go. Exactly. Kyle's got you. So if you have an idea. So what I do is I go to Dribble. How would you do this? Go to Dribble, and then look at designs for landing pages. And then you get a whole bunch of ideas here, a whole bunch of designs. And then you can copy that and paste it into an AI and have it build it for you. There you go. I need the future. You use Pubnub for your startup. That didn't take off, and it enabled me to build a source delivery platform like in a month, which was awesome. Made people wonder how the push notifications worked. Isn't that neat? It's like magic. It's magic. That is fantastic. That is, Savan, that's amazing. That's crowd, gotcha, crowd. A crowdsourced delivery platform. Nice. You're doing it the right way. Python. Let's make sure this works again. I want to double check. Click. Okay, looking good. Okay, yep. Are decoded. Excellent. Although it says negative, so we should probably do... Can we do a... I think it's fine. It doesn't matter if it's negative. Oh, that's very weird that it's negative on the output. What we could do, is there a torch.sigmoid? Sigmoid. Can we do that? Is that something we can do? I don't know. We'll find out. Click, 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 click. Yes, we can. And now it's correct. Hey, there we go. Also, the decode should not be a float. Could it be though? If we'll keep it into... Should we keep it? I think that's fine. I think it'll be a float. It's fine. A float is fine. We're good to go. Okay. Decoder. Oh, that's why right there the whole time. Oh, all right. I get it. I understand. All right. Encoder. Now we can do that. Okay. It's because of something I did earlier. So this should work perfectly fine now. Just the way it is. Okay. Here we go. All right. Click, click, click. Looks good to me now. Okay. Now we're optimized. Now we're looking good. Looking good now. It was like 13 years ago. Yeah, yep, there you go. And Steven would respond personally to some of the clients back then. Yeah, I would. And I was one of those lucky. Nice. Savannah that's amazing. That's amazing. I still work with customers. They tend to be big customers though. These days, I write most utils and use again for my because they will be better, but because it's more, and there is less friction. Just playing, that's the way to do it. That's the way I like doing that too. I really do. I think that's my preferred approach. Quantify Quantum. Stephen, have you ever used Walrus Operator? Walrus Operator? You know, you've got a fun name for it, Quantified Quantum, but it's possible that I have. Walrus Operator Python. What is this? Is it like a colon equals? What is that? How does that work? What is this? What is this? I don't think I've ever used... I might have used it like a long time ago. Nope, not that long ago. It's only been available in 3.8. For assignment expressions introduced in 3.8, it allows you to assign values to variables within a larger expression. Oh. Okay. So you can assign data. Where is this? So here's the difference. Okay. So you can use this type of syntax. So this is the original Python original syntax. However, with Walrus Operator, you can do it in 2 lines instead of a whole bunch of lines. Isn't that nifty? Okay. That's pretty... Got it. Okay. Nice. Walrus Operator. Quantified Quantum, thank you. Thank you for sharing that. We'll try to remember that in the future. We need to become an expert. I think that's the way to do it. So when I started building a game, I need my own UI library. Of course. Definitely. You got to start with a UI library. All right. Let's see if we can get back into it over here. All right. So now that we've got the full forward pass, encoding and decoding, and we're using all of the torch data with the tensor, looking good. Now, we don't need to, I don't think we can clear all that out. So we can get rid of that. Okay. Looking good. All right. Now we need to train it. All right. So we've got the data in the forward pass. Now we should also run a train. We should run a train on one sample. Every single sample we should train it. I think we should, whenever we get the data, we should also run train. Features and labels. So let's get going here. Reminds me of Walrus Operator because it looks like its teeth. It does, yeah. That's probably exactly why they called it the Walrus Operator. It's got fangs. You got it. It's got fangs. Exactly. Okay. So now in order to win, in order to achieve our objective here, we've got a predictor, predictions. Here we go, predictions, click. All right, number of clicks, features, labels, predictor, output. We need to train here. So that would be the predictor dot train features and then label. I think we'll do label here, comma label. There we go, features and label. And instead of doing this, we don't need to do this, I don't think. We'll just train it, and then we need the output here. Do we though? Because otherwise we're just running it through twice. We don't need to. We don't need to do it twice. We only need to do it once. Okay. All right. So how do we want to go about this? Let's think this through. All right. Train needs to run a forward. Okay. So where is this at? We'll do self.forward features. Output equals, and then we need to do our, here we go, let's look this up, forward project AI game, game.ai. All right, train, excellent. All right, so right, okay, so we need to zero our gradients, which will be self the optimizer, I'm pretty sure. Because I think we have the optimizer defined here. Yep, yes we do. We got it defined there. Zero the grads. All right, We don't need that because we've got a full chain. We've got the full chain in the forward pass, so we no longer need to do any of this extra magic stuff here. And then we need to backward, right? So we need to get the loss, and then we need to step. Okay, perfect. So we got to do these things here. Oh, right. We could also, is there, I don't know if anyone knows on chat, is there a way in Pytorch to properly calculate and track the cost of the training of the model? I know how to do this by hand. It's really easy. It's really easy. It's a line of code. Is there a native way in Python with Pytorch to track the cost? Or just, I mean, the loss is obvious because I've already got the loss here. But the cost, I'm looking at for the cost. So what I've done in the past is just append to an array and then just track like the last 500 elements. That's what I usually do. In our case, since we're tracking the clicks, we probably don't need to cap it, but we probably should add a cap of 500 in there. I think that would be good. So we need to, here we go. We do self dot loss is the loss. Okay, that should work perfectly fine. I think that should look good. And then what is our loss function in MSE? MSE probably fine. I think that's fine because it's not a classification. It's going to be it's going to be a smooth number. It's going to be a smooth number. Okay. And then we could do loss dot backwards and then self dot optimize. Self optimizer step. Okay. This should do the trick, and then we could say return output. Excellent. Excellent. Okay. I think we're on the right track here, you guys. I think we've done it. I think we've figured this out. Kyle, Steven, you should make the AI from Metal Gear Solid with the cone field vision, but minimap version. You always make the AI overpowered. That sounds great. I like that idea. We do a vision cone. That AI though, let's think that through though really quick. The AI, if it only needs to, I mean, it's just a collision detection at that point, right? Because you've got the minimap and it's a triangle cone, right? Here, let's do MSG mini map. See, let's do MSG mini map. Here we go. Metal Gear Solid minimap images. Where is that at? PSX. Let's do PlayStation. 1 second. PlayStation, please. Play PS1. Well, Reno, thank you for following. Thank you for your follow over there. Hey, I really enjoyed. Nice. Here, you seem cool, but I noticed you have, okay. Thank you, Reno. Thank you for your follow. I appreciate it. Okay, 1 second. That is, here, let's just type Metal Gear Solid minimap. Here we go. Okay, Kyle, this is what you're talking about. These guys right here. So zoom in on that. Yeah. We could do that with the red dots and they sort of move around. That would be kind of neat. It just sort of tracks and it walks around and it tries to find the player. That's a pretty fun one. I like that. It's a good idea. Okay. So we've got our train. We've got our forward. We've got our encoder and decoder. All happy. Using all of the native Pytorch math operations. So we're good. We're doing good here. Now we need to, let's see, where's this train at? So train is here. Output, print. And then this will be the prediction, right? So this will be the prediction of where the user's going to click next. Prediction equals, well, actually, let's do this. Prediction, there you go. Print. Let's see, 1 second. Carter Goodwin. Have you played Dungeons and Dragons? Yes, I have. I've played Dungeons and Dragons in many shapes and forms. Tabletop RPGs. I've played them in the form of Baldur's Gate in the early days. Various games and RPGs. Make it a Unity extension or something. That would be pretty great, because then we could actually release something that's useful and usable by other people. Yes, you're a dungeon master? Nice, Carter. Carter Goodwin, dungeon master. Very nice. Do you use inheritance at all in your project? I do, very, very softly, because for the most part, and it depends, you typically only need to make one of something. You don't need to make many of some things. So you don't necessarily need to have a whole bunch of inheritance, because you're only making one level deep. Let's go. I know we're doing it, Neva. We're almost there. We're so close. We have the full feed-forward neural network encoding and decoding. And we've got the training code. I do believe the training code works. We're trying it out now. Print F this. Here we go. Prediction. Let's make that nice and pretty. Here we go. Paste prediction : will be a prediction. Paste. Good. All right. Okay. So let's run this and see if it works. I'm pretty sure it will, and it should start. And now all we have to do, I believe this is it. That's it. We basically did all the hard part. We should only have to be able to paint the picture, the graphic, where we think the AI is going to think the user is going to click. Have you ever written an inheritance for something other than what you're forced to from Pytorch and like? Yeah, of course. I've made games. I've made, lots of software, though I tend to stay away from inheritance. Good night, bro. I'm going to sleep. Nice, Karmu. Thank you for spending time with us today. Happy Monday. You made it. You made it to the important part because we did the stuff. We made it work. I find I basically never use it too. Never, other than interfaces. Right, never? Exactly. It's like very rarely do you need to use it. I believe you never need an inheritance in any code unless it is a scriptable, which is a user script or layer 1 from the UI library. Yes, exactly. You got it. It's a nice way to encapsulate code. You don't necessarily need to inherit from anything else. Otherwise, you're creating extra abstraction, which adds complexity into your code, introducing added technical debt. So for the REST interfaces, or REST inheritance is BS in any other scenario. You're absolutely right. For REST APIs and for server send and receive data, you do not need inheritance. You just don't need it. It's not a thing you need. You do not need it. It is no need inheritance. Yeah, like when you're forced to because of some API like Pytorch game level. Yeah, there is. So exactly. So in this case, we are forced to, as you can see here on the screen, we are forced into it. We are absolutely forced into it. It's fine. All right. We don't need that anymore. I'm keep it there for now, just in case. All right, let's see if it works. We should get an AI that should be predicting now. Okay, did I spell it wrong? Tuple object has no attribute. Optimizer, 0 grad. We don't? We'll figure it out. Okay. Let's see, 1 second. I still need to get this. I still need to add the cost and loss so we can track it. Protocols are the best way. Duck typing. Oh, right, duck typing. Because it makes a quack sound, right? Because it goes quack. The duck quacks without the hold of the back of the inheritance and abstract classes. Idiomatic Python. The Pytorch API is made as such with callbacks. I like your callback. You meant callbacks. So we have not much choice. Got it. It is, yeah. Python's kind of that way. Inheritance is only useful if you know you need everything from the parent. And that is almost never just playing. You're right. It shows that you have been in software engineering for long enough that you've realized this. It is just such a rare scenario where you actually need it. Some of the challenge, though, is legacy and early applications and projects that are built from researchers from like educational institutions. They are often teach you that inheritance is the way to write code in general because it's well organized or something like that. It's not. In industry, it's not. And the problem is a lot of that code isn't actually adopted in industry, and so we are stuck with it. We get Java. Yeah, I know, Java. Exactly, Java. Everything from the parent. You got it, Java. You know what you're talking about. Callbacks. Yeah, I figured. Massachusetts Information Technology Institute of Technology, MIT. You got it. Okay. So, I believe this looks good to me. Oh, wait, 1 second here. What is this? What am I looking at? Why is that here? Event hooked push. This is weird. What is this? What am I looking at? This looks weird. Oh, why is this? What is this for? Self.push. I need to figure out what's going on here. What is this? All right. To do what? What is that? We need to figure that out. What is that? I started writing code a year ago. If you only started writing a year ago and you've already realized this, you are otherworldly. You figure things out so quick. Pytorch, you need superclass and plug in your algo neural network architecture and then let it do it behind the scenes things. Yes. Pytorch is actually binding to C++, libtorch, yep, and torch vision. You got it. Yep. So we're actually using, a C library, C++ library. What does MIT stand for? Mind Intelligence Turbulence. SAQ 3000, you got it. Yo, can you add me as a name in my... LTR veteran. I saw what you did there. You think I can not realize that? Okay. So I need to figure out what's going on here. Before we do that, though, event hook, blah, 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 blah. If event, let's see, print. Okay, so I did print it. What is going on here? Is there another? I know there's another push. Okay. Oh, it's a meth. Okay. All right. I know what's going on now. It just was not obvious. Okay. This function's not used anywhere. And so it's kind of weird that it's being used here. Let's see. La, 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 la. If event is a mouse button. If event button is a left button. This needs to be indented, right? Double check that works. Click, 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 click. All right, looks good. Okay. 0. Do we not have an... Oh, that should be fine. That should be absolutely fine. Why is that not working? Why is this not working? Self-to-optimizer. That should work. That should work perfectly fine. I'm pretty sure. All right. What language? This is Python. This is Python, you guys. Do you know Stray Kids? I do not. I don't know what that is. Rachel Brown, what is it? What is that? Is not almost any Python library written in C? Yeah, you're right. A lot of the libraries, for performance perspectives and reasons, are written in C, and then you import them, FFI or other ways, into Python. I know it's university. Everyone knows. I'm curious. MIT, Massachusetts Institution of Technology. Right? I'm pretty sure, right? Also, Google and ChatGPT should know. Let's see here. Yes. Now there is a Rust shift. Yeah, Rust shift. I know. Since Rust has incredibly superior bindings to Python, it's so easy. We've done several live streams where we've taken Rust, we wrote code in Rust, and we've easily imported it into Python, and it was just seamless. It was so wonderful. It was so wonderful. You're absolutely right. Rust, you're right. Savan, you're totally right. Massachusetts Information and Technology. You got it, Kyle. You got it. Hope everyone who celebrates has a great holiday. You too. C++ has some good bindings. It does. It's actually pretty good. Okay, so where is our problem? It says this is a problem. I don't think that's a problem. Here, let's just do this really quick. Return 0. Okay, let's make sure that our code still works. Click, 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 click. Looks good. Happy, 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 happy. Looks good, looks good. Pro macros is really good at binding things. I don't know about that. What is that? What are pro macros? Your ping went to 1400 in CS2. That seems like a high ping. I guess it depends on what you're pinging. Rust and Python should get married. They're good neighbors. Let's say that. So there might be an opportunity. You never know. You never know. All right. So why is this not happy? Let's look this up. All right. So I've got some code here. Where is this at? See, grad 0. No. 0. Here we go. How do we... Where's the optimizer at? All right. Optimizers. Perfect. This is what we're looking for. Okay. Where is... there? So that's the model. Learning rate, optimizer, loss function, cross entropy. We're not using cross entropy. Where is it? Optimizer.zeroGrad. That's exactly what we're doing. Optimizer.step. Oh, we went the wrong direction. Okay, so I suppose we got to do it this way. All right. Let's see if that works. Okay. All right. Let's try this out. Let's see if this proc macro. Oh, proc macro is a macro that allows you to run arbitrary code. Oh, really? Okay. Tuple object is not... Okay. Loss. All right. So we can figure that one out. All right. I think we're a step closer here. We're a step closer. Loss. Here we go. Let's close that out. Let's just do that really quick. All right. That should work perfectly fine. I don't see why that wouldn't work. That should work. All right. Perfect. Stuff is about reading in Python, variables and property. Like it's a good pro macro that make a bunch of unsafe Rust. Oh, really? That seems like a problem. They are in open relationships, right? It's kind of Rust and Python. You got it. It's really high. Normally we would find 80 high. 80 is pretty high as a ping, right? For a ping, if you're trying to do it based off of a local sort of ISP, you're doing like benchmarking on how fast your internet is. You're doing a speed test. You want something that's called zero ping. Zero ping, it's not actually zero. It's just below a millisecond. So most of the latencies are reported in milliseconds, and you can get zero ping if you get a ping that's below 1 millisecond. I used to have zero ping. It was so good. I had Google Fiber in San Francisco. It was wonderful, and I miss it so much. I've gotten used to slower, though. Maybe unsafe bits are generics? You're not sure? Okay, got it. But you are forced to do unsafe to talk to Python since you have to... Oh, really? C-structs would be read into the Rust and dropped properly in? I didn't know that. So you have to do unsafe. this whole time. No, to the game server. Oh, got it, to the game server. Okay, yeah. 80 is okay for the game server. A lot of times, even hundreds are okay, right? Even 400 or 500 ping. Game servers are built with latency mitigation built in that allow you to play a game even if you have a pretty high ping. You typically want to be around 500 milliseconds, and that's fine. 80 is still good, though. If you're playing a fast first-person shooter, you might be hitting some edges, though. Yeah, like anytime you talk between two languages, you have C in between, and that's inherently not safe. There you go. There you go. Makes sense. Okay, so let's see if we can get the training happening here. Can we do the loss? Can we do the loss function? Is the loss function going to work? It is not working. Okay. It self.loss. Why? Oh. Should that... Here, let's read the docs. Okay. Loss function. Where's this at? Where's our loss function? LOSS_FN. Oh. Okay. So it's going... Oh, got it. Okay. 1 second. Hold on. Okay. So we're doing it right. We're doing it right. Prediction, and why with the labels. Unless, wait, hold on. Wait, let's check this. Labels might need to be this. Right. Let's double check that. All right, click this. Click. Not tuple object is not callable. Loss. Okay. Did we do this wrong? Oh. Yes. Okay. I see what's going on here. Okay. Did you guys see that? I hope you didn't see. Well, I hope you did. Because if you saw that and you just realized just now, there was a comma at the end of my assignments. And that creates a tuple, and it's syntactically correct in Python. So the fix is to get rid of the comma, and now everything should be fine. Now it should all be perfectly fine. All right, here we go. Do we need to... Hold on. Let's double check here real quick. What is the output? All right, so print CF output. It's going to be output. All right. I want the loss. Let's see. Wait. I want the features and labels. I want to see everything. I want to see all of it. Label, features. Okay, and then the loss. All right. Okay. Let's take a look at all of this. I want to see everything. Wait, we can't. Output has to be up here. Okay. I can feel really heavily. It's longer in my reaction time. Is it? Yeah, it is. You can feel it when the latency is there. Yes, tuple context coercion. Sorry for using Perl terms. Hey, that's regular terms. You're using it regular. Perl. I used to write a lot of Perl. Back, Amazon.com used to be heavy in Perl. It was a lot of Perl. And that's where, because I, grew up here in Seattle. So Perl was a big language for us here in Seattle, Washington. Hey, Torva, you made it in. Hey, good to see you. We're getting our click to work here, our click tracker. And it's about there. We're almost there. We've written the whole unbroken graph Pytorch neural network with encoding and decoding layers. You can see it right here. Unbroken. We've never done this before. This is my first time. I've always broken the graph by writing my own logic in the middle. Me too? Nice. That's awesome. Perl's the way to go. Love Perl. I haven't used it for a long time though, because there's other stuff to use now. Have you seen the U.S. military tech classes that see through walls? Nope. I've heard about them in cartoons. I think The Simpsons maybe? The Simpsons? Okay. I want to see if that looks good. The only thing is, are we putting the 0 grad in the right spot? I think we are. Let's double check that. It wants us, it says loss backward optimizer step 0 grad here. Okay. So that should be exactly what we have here. Loss, backward, optimizer step, and then grad. Okay. Self. There we go. That should do the trick. Excellent. Okay. It was your sysadmin got into it and Ubuntu made you switch to Python. Oh, really? That's the way. Yeah, that's basically what happened to me too. Well, I mean, not actually when I said that, I mean, that's not at all how it happened to me. It's just that Python was the way around. Okay, so. Okay. Wait, let's read what we got here. So, output is a 2-dimensional array. Labels. 100? 100? What is this? That's not correct. That's weird. Okay, so that's what the problem. Train, label, features, label, train, label, clicks. 100 oh, okay. Here, Python 0, 1, 2, 3, 4. -2 is incorrect. It needs to be, I think it's got to be, is it this? Yes, okay, I just need to put a colon, and that's it. 4, 3. Okay, I just got to put a colon. All right, perfect. Colon. There we go. That should be it. That's the answer right there. Hey, Steven. Let's see here. I'm a data analyst. Panda, Python, NumPy, data analyst manipulation, looking to getting into a career in machine learning, engineering, AI. Do you have? Yes, we've got an open role. Let me post it for you. We've got one open role here at PubNub. So let's look at PubNub careers. Click this button. We've got a couple open roles. Let me see here. Go right here. Click the button. Here we go. I will paste this into our Discord channel under free resources. There you go. Free Oholics. Oholics. There you go. It is in our Discord. A link right there. So I just high sensitive thermal maybe UF. It's through walls. You probably could do like there's if you had enough, electromagnetic radiation that's occurring that can pierce through walls, like Wi-Fi, for example, you can visualize that, capture that in a photosensor, electromagnetic sensor array, and convert it to visible light for a human to see through walls. You can do it. In fact, we could probably make it ourselves. Keyword eagle eye. You got it. Keyword eagle eye. Nice. Some sort of roadmap and to give you a better understanding and perspective of the whole thing. Thank you. You're welcome. All right. So, here we go. Features, labels. That should not crash this time. Let's see. That's what I said every time. It's always crashed. See, it crashed anyways. All right. List has no attribute size. Does it need to be a tensor? I don't think it needs to be a tensor. Do we need to unconvert it from a tensor? Do we need to say .2 numpy? Is it a problem with our decode? What is add to-do list? I don't know. We got to add the to-do list next stream. Maybe, because we're at 2 hours here, and we usually only stream for about an hour. I really would like to get this going. So I've got, where is that at here? Look, so it's just returning straight up. From here. So that should be perfectly fine. And then where was the optimizer? Here, let's go. Here we go. Right around here. Here we go. Excellent. Output pred looks good. Model. That seems fine to me. I want to see through walls. Steven, teach us. We could do it. We could absolutely do it. We just need to get a electromagnetic photo sensor array, which is kind of like a camera. Like you see a camera, although that is capturing photons in the visible spectrum. And so we need to be able to do electromagnetic capturing, which is what a photon is, right? It's an electromagnetic wave. And then just capture it at a different frequency. So that's it. And then we upscale it or upconvert it to visible light. And you could see through walls. You could totally see through walls. But you need something that's shining through on the other side, right? You need something that shines through, which is like a Wi-Fi signal or some sort of other radio signal. And then you can see through walls. You got it. You got it. All right. What is wrong with our program? We're going to figure it out. We're going to figure it out. All right. So it's unhappy here. No, it's got, all right, train, output, loss. It doesn't like this. Is that, wait, why not? All right. Let's look over here. Labels. Labels. Looks good. It's a single array. And then what is the output? It also looks like a single array. So maybe we've got the wrong dimensions. Maybe we got to do it like that. Is that the problem? Do you think that'll be it? Subject AI, yeah, how's it going? Hey, will this video be on channel after live? Yeah, it'll be the VOD, the video on demand will be available forever. I also do an editing of the live. So after I have it run through my own workflow. Sounds rad, isn't it? Isn't it neat? We'll be live tomorrow and we'll be continuing this. I think we got really close. We might be wrapping up here. We might be wrapping up. We'll see. We'll see. We'll see how it goes. Let's see. Okay, so we're doing good here. We're doing good. I want to figure out. I just want to make sure that this works, and I want to commit it to Git. Thanks. I'll see you later. See you later. Nice. We're almost done here. Okay, so it's still a problem. Target size, input size. The target size is not equal to the input size. Well, of course, labels. And the output is, that looks correct to me. What is the size? List object has no size. Oh, it wants it to be a tensor? Do we have to convert it to a tensor? Is that what this needs to be? It needs to be a tensor. Is that what it wants? Let's find out. Let's find out. Labels equals tensor labels. All right, there we go. Little variable shadowing there. Okay, kind of understand them. Now, like a neural network uses data from electromagnetic waves. Yeah, you could do that. And the thermal view to display the locations and make sure they are accurate via AI. Torva, you're talking about a really neat product right now. That would be a lot of fun to build. And then we could sell it to anyone. Although the government might say, hey, this is too powerful. It's too powerful. That technology you got right there, it's too powerful to be in the hands of common consumers. You have to sell it to military-only applications. Hey, Andrea. Hi, how are you? I'm doing good. Thank you for asking. And for my earlier question, oh, wait, 1 second. Let me see. Savan says, hey, Steven, it's getting quite late here. Okay, unfortunately, you have to go sign out. All right, thank you for spending time with me, Savan. That was great to have you here today. It was really great. Catch you next and have a good connection. Nice. Sounds good, Savan. Thank you for spending time. It was good to see you. From your earlier question, what do you think is best to start on from data analyst caliber? Explain initially, going from pandas and NumPy. Okay, so I've got your answer here. I like this. This is my favorite. So there is a Keras TensorFlow tutorial. It's very easy. It's very short. This is it right here. In fact, I can zoom out. You can see it all. This is it right here. This is all it is. And here, I'll paste it into our Discord channel. I usually paste it over there. So under free resources, there you go. I recommend starting there. I think it's a really good place to start. That is the new Eagle Eye technology from the U.S. military. It is. We can make it. We know how to make it. China just entered the chat. Yeah, I know, right? Got to be careful. They're here for the technology and they're going to copy it. That's their favorite thing to do. Got it? Okay, nice. You're welcome. You're welcome. All right, click, click, click. All right, still crashes. MSC logic. Oh, good, good, good. Okay, has no attribute backward. Well, why not? Oh, because it needs to be that. Okay. Okay. All right, you guys. All right, you guys. Did we get it? Oh, so close. It's so close. Why does it not like this? What's going on here? Now we're really into it, aren't we? That was the biggest error I've ever seen. Oh, hey, track the loss. We got the loss there. Check that out. Okay. Features, labels, output. Calculated loss. That seems really high. Do we want to encode and decode? Meh. Meh. Hey, man, Merry Christmas. Merry Christmas to you, too. Merry Christmas. All right, so let's play some Christmas music. Let's do contemporary instrumental Christmas. Here we go. Now we've got a new vibe, and it's Christmas. Okay. Loss, backward. Where does it... All right, let's close these off here. See if that's the problem. Okay. That seems like that might be the problem. Okay, click, 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 click. All right, good, good, good. All right, good, good, good. All right, nice. Okay. Excellent, excellent, excellent. This is what I like to see. All right. Predictor. Is it training? Weird. As I'm clicking, the loss should be reducing. It seems to not be. Oh, because we're not training the model yet. Okay. All right. So, loss. Why does it not like that? Is that because it's too big? Geechee. Geechee. Hey, how's it going, Geechee man? Welcome on in. Merry Christmas. Merry Christmas. All right. So we got a problem here. Found D-type long but expected float. Oh. Oh. Okay. I can figure that one out. Here we go. All right. Convert, please. Convert the number type for me, please. Pytorch. Convert it into a floating point number for me when you're importing it into your tensor. Hey, there we go. All right, all right. Looking good now. All right. So we should be able to optimize, and the loss should continue to drop as we click. Click, 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 click. Good, there we go. Is the loss reducing? Loss is reducing. Loss is going down. There we go. There we go. We did it. And is it learning? Is it learning fast enough? I might want to increase the learning rate. All right. Is it good? Is it good? Yeah. I'm just going to keep clicking. Hey, we're doing it. Hey, those loss. Don't click that. Look at that. The loss. Oh, wow. That is amazing. Oh, that's so good. That is so good. And yep, it learned. It did it. Okay. We figured out. Merry Christmas, brother. Hope all is well. We got a results of trading bot. Oh, right. That's right. The trading bot. Curious on results. We still need to make it better before I really run it. So we will be doing more of that. So we'll be doing some algorithmic trading again in the future. Torva. I know. Hey, Torva, we did it. Look at this. Great. There's like real numbers here. So I need to. So this is great. This is exactly what I'm looking for. I'm very happy about this. This is looking good. Yep. Okay. I want to increase the learning rate though, so that way it can go a little bit faster because I can't click that fast. We did it. All right. So what we need to do. So here's what we'll do. Next stream tomorrow. Next stream, we will visualize where the AI thinks the click needs to occur, and the user will click, and then the AI will. Before the user even clicks, the AI is going to figure out where the user actually clicks. However, in order to prevent the AI from informing the user and affecting the user's decision, we want to make sure that the AI won't modify the future. So we only can print the output of the future after the user has already made their decision. Otherwise, we'll influence the user's decision. So that's what we'll do tomorrow. That'll be the plan for tomorrow. All right. All right, everyone. Thank you so much for joining today. We'll commit the code here. What we need to do. Let's write. Let's see here. Let's see to do. See. So next to do. What we do next here is display where AI thinks next click will be. Increase learning rate. And then we'll see if we can get it to work. So that'll be the plan for next stream. That'll be the plan for tomorrow. All right, everyone. Sounds like quantum mechanics. It kind of is, right? Because you can influence the future. And if you do that, you might change the future of what the future actually would be. And it kind of is. It's kind of the future. So that's what we'll do. All right, everyone. Thank you for hanging out with me today. We'll be back tomorrow. We're wrapping up now. Join our Discord for future streams. We'll usually go live around this, live between 10 a.m. and 2 p.m. That's what we usually do. It's been a pleasure, Torva. Yeah, exactly. Kyle as well. And Geechee Main. SAQ 3000. Thank you for spending time with us. We'll be back on Tuesday. See you all tomorrow. We'll be back tomorrow, everyone. Thank you. Always love your streams, brother. Oh, thank you. Thank you for saying that. Thank you so much. Holax. Thank you. We'll be back tomorrow. It was great fun. We'll finish this up. We'll actually show. I need to commit this really quick. Git status. Git commit -am. Full AI. Full ML training and optimizer. Good. We did it. And then a party popper. Push to main. Done. Boom. Uploaded. When exactly is the next stream? Maybe. It'll. Let me check my calendar really quick. It'll be tomorrow around 10 a.m. Pacific. 10 a.m. Pacific. So about the same well, a little earlier maybe a little bit earlier. So that'll be the plan. So about the same time tomorrow, but maybe a little bit earlier. That's the plan. All right, everyone. Thank you. We'll be back tomorrow. See you guys.